Hey guys, it's Peyton. Let's take a look at connecting the standard form for a quadratic equation to the vertex form for a quadratic equation. And let's do a little refreshing here. The standard form for a quadratic equation is y equals ax squared plus bx plus c. And the vertex form for a quadratic equation is y is equal to a times the quantity x minus h squared plus k. Again, we're trying to get from standard form to vertex form, so we're going to transform ax squared plus bx plus c to a times the quantity x minus h squared plus k. We're going to do this modification using the completing the square method. If you need a review of this method, please see Module 4, Lesson 9 online. We're going to turn to a pictorial method using algebraic tiles. Bear with me as I lay down the foundation for this method. Here we're going to use squares and rectangles to figure out what we need to add to our equation. We're going to let the green square equal 1. Think of it as an area. One side has length 1, the other side has length 1. 1 times 1 equals 1. Okay? It has a negative, which is this red square. Now, I know that we're dealing with area, but we're going to let it slide this time. The area of this is negative 1. Then there's the green rectangle given as this. It denotes x. The height is equal to 1, but the width is equal to x. X times 1 equals x. It also has a negative, denoted as this red rectangle. Its area is negative x. Then there's the square given as this. Its area is x squared. It has a height x and a width x, so x times x equals x squared. And then its negative is this red square. Its height is x and its width is x, but it's negative, so it's going to be negative x squared. Okay, here's an example of how to use this method. Given an equation x plus 3 times x plus 2, find the quadratic it's equal to. We could do this algebraically, but let's use these algebraic tiles. I'm going to say that x plus 3 is equal to 1 green rectangle plus 3 small squares. The x plus 2 is equal to 1 green rectangle plus 2 small green squares. Now we have x plus 2 times x plus 3, which can be visualized as this. Looking at this picture, we have one big large x square, and that's from the x rectangle times the other x rectangle, which gives us that very large square. Then we have x times 3, which is 3x, and there are 3 vertical x rectangles. Then we have x times 2, which is the same as saying 2x. And we have 2 horizontal x rectangles. And then we have 3 times 2, which is 6, and so we have 6 small green squares. To finish this, we will add up all the boxes and rectangles accordingly. So we have one x square box, we have 5 x rectangles, and we have 6 1 squares. And the equation will equal x squared plus 5x plus 6, which is in fact the same solution we would receive if we did this algebraically. To use this method with completing the square, we aren't going to know what the multiplying parts are. We will only know part of the actual product and are going to add what we need in order to create a square and work from there. Let's work some examples, and I'll explain each in detail and the method behind them. First, we'll look at when a is equal to 1. Here's our first example. Transform this equation to vertex form. Y is equal to x squared plus 8x plus 9. First, we realize this is in standard form. A is equal to 1, b is equal to 8, c is equal to 9. Now the first step to completing the square is to move the c value to the other side of the equation to isolate the ax squared plus bx. To do so, we will subtract 9 from both sides, and our equation will now become y minus 9 is equal to x squared plus 8x. Now to complete the square, take half of b, square it, and add it to both sides. Here b is 8, and half of 8 is 4. 4 squared is 16, so we're going to add this to both sides of our equation, and now we'll have y minus 9 plus 16 is equal to x squared plus 8x plus 16. Let's look at this using the tile method. Here's what we would have from the equation ax squared plus bx. Here we have an x squared box and 8 x rectangles. Notice how we have equally distributed the x rectangles. Now the goal is to create a square by adding enough 1 boxes to our diagram. We have to add 16 1 squares, which corresponds to us having to add 16 to both sides algebraically. And here's what our equation looks like algebraically again. We have y minus 9 plus 16 is equal to x squared plus 8x plus 16. Now we can simplify the left-hand side of the equation, and on the right-hand side we want to factor it so that it's something squared. By using the square, we can figure out that pretty easily. Just take whatever half of b is, sum it with x, and square that quantity. Here, half of b is 4, and we want to sum it with x and square it. So the equation now becomes y plus 7 is equal to the quantity x plus 4 squared. Let's take a look at the tiles again. We can find from our diagram what we should have squared. Here we're looking for whatever x minus h is. First, let's determine what goes across the top and along the side in order to produce this square. I claim that each side should have one x rectangle and 4 1 squares. If we look at our equation, y plus 7 equals the quantity x plus 4 squared, we have x plus 4 squared, which is what we received from the tiles. Now, again, back to the algebra, we want to simplify it so that it's y equals something. Here's our finished equation. Y is equal to the quantity x plus 4 squared minus 7. We have now accomplished transforming an equation from standard form to vertex form. Let's work another example. Transform this equation to vertex form. Y is equal to x squared minus 4x plus 19. We will use the completing the square method again, so the first thing we need to do is to move the c to the other side of the equation to isolate ax squared plus bx. And we'll do this by subtracting 19. So our equation now becomes y minus 19 is equal to x squared minus 4x. The next step is to take half of b, square it, and add it to both sides. Here, half of b is negative 2. Negative 2 squares 4, so we'll add 4 to both sides, and our equation becomes y minus 19 plus 4 is equal to x squared minus 4x plus 4. Word to the wise, you will always add something to each side. You will never subtract it. Let's take a look at using the tiles. We have one x squared box and 4 negative x rectangles. Now we need to add the correct amount of 1 squares. Also, we need to keep in mind that there are negative x rectangles, but a negative times a negative equals a positive. So we can only add positive 1 squares. Here, I've added 4 1 squares, and we've completed the square. Now let's simplify the equation and unfactor the right side. So y minus 19 plus 4 is equal to y minus 15, and then x squared minus 4x plus 4, if we unfactor it, will be x minus 2 quantity squared. Again, let's take a look at the tiles and see how we receive the x minus 2 squared. We need to put the correct tiles along the vertical and horizontal lines so that their product equals the square we have. I claim the tiles along the line should be 1 x rectangle and 2 negative 1 tiles. The negative 1 tiles are there because we have 4 negative x rectangles and 4 positive 1 tiles. Just think of it as multiplication. Add what you need. Let's jump back to our algebraic method where we left off. And here's what we have. Y minus 15 is equal to the quantity x minus 2 squared. Now let's add 15 to both sides to isolate y. And in doing so, we will have y is equal to the quantity x minus 2 squared plus 15. And that's the end of our transformation. Let's work another example. Y is equal to x squared plus 3x plus 21 divided by 4. This one's going to be a little hairy because of the fraction, but it's manageable. First, we need to move c to the other side of the equation. So we will subtract 21 divided by 4. And so our equation becomes y minus 21 divided by 4 is equal to x squared plus 3x. Our second step, take half of 3, which is 3 halves, square it, and then add it to both sides. 3 halves squared is 9 divided by 4. So our equation will now become y minus 21 divided by 4 plus 9 divided by 4 is equal to x squared plus 3x plus 9 divided by 4. Third step, let's simplify the equation, including unfactoring the right side. Remember to take half of b, add it to x, and square that sum. The left-hand side of our equation will simplify down to y minus 12 divided by 4, and that will equal x plus 3/2 that quantity squared. Let's simplify a little bit more. 12 divided by 4 is equal to 3, so our equation now becomes y minus 3 is equal to the quantity x plus 3/2 squared. Now let's modify that so that it's y equals something, and we'll add 3 to both sides. So the equation now becomes y is equal to the quantity x plus 3/2 squared plus 3. That's our equation. The fraction made computations a little hairy, but we got through it. It's manageable. We're done. Let's try some transformations now when a does not equal 1. Here's the method. First, we still want to isolate ax squared plus bx by moving c to the other side of our equation. Our next step is to factor out a. Then we will complete the square, remembering to add the appropriate number to each side. This is the tedious step. Then we're going to simplify. Let's work an example, and I'll show you the inner workings of this process. Convert the following equation to vertex form. Y is equal to 3x squared plus 24x plus 44. First, let's isolate the ax squared plus bx, so we'll subtract 44 from both sides. And our equation will now become y minus 44 is equal to 3x squared plus 24x. Now we need to factor out 3 from the right side of our equation. And our equation will now become y minus 44 is equal to 3 times the quantity x squared plus 8x. Now let's take half of b, here it's 8, square it, and add it to the inside of our parentheses. And half of 8 is 4, and 4 squared is 16. So our equation becomes y minus 44 plus t is equal to 3 times the quantity x squared plus 8x plus 16. Looking at the equation, you may be curious where the t came from. Instinctively, we may assume that t is equal to 16, but that isn't correct. We have to account for the multiplication of 3 on the right side of the equation in order to preserve equality. Now here's the trick. T is equal to a times the number that you added to the interior of the parentheses. Here, t is equal to 48. 3 times 16 is 48. Thus, the equation becomes y minus 44 plus 48 is equal to 3 times the quantity x squared plus 8x plus 16. Now we simplify and complete the square, and negative 44 plus 48 becomes positive 4, so it's y plus 4 is equal to 3 times the quantity x plus 4 squared. Now let's modify the equation so it becomes y equals. We'll minus 4 from each side, and it becomes y is equal to 3 times the quantity x plus 4 squared minus 4. And we've completed our task. Now let's do a quick little recap. We isolated ax squared plus bx, we factored out a, then completed the square according to the multiplication by a, then finished by making the equation y equals. Let's work another example. Y is equal to negative x squared plus 4x minus 1. Here, a is equal to negative 1, so we'll need to factor that out at some point. But let's first isolate our ax squared plus bx by adding 1 to both sides. So our equation now becomes y plus 1 is equal to negative x squared plus 4x. Now we can factor out the negative 1 on the right side of our equation, and thus the equation becomes y plus 1 is equal to negative 1 times the quantity x squared minus 4x. Now to complete the square. Take half of 4, square it, and add it to the interior of our parentheses. And we'll add that number times negative 1 to the left side of our equation, and so it becomes y plus 1 minus 4 is equal to negative 1 times the quantity x squared minus 4x plus 4. Okay? We're good so far. Now we simplify and we complete the square. 1 plus negative 4 will be negative 3, so it becomes y minus 3 is equal to, we'll complete the square on the right-hand side, negative 1 times the quantity x minus 2 quantity squared. And let's modify the equation so that it's y equals by adding 3 to both sides, and it becomes y is equal to negative 1 times the quantity x minus 2 squared plus 3. And we've gotten to vertex form. We're done. That'll finish looking at transforming quadratics to vertex form. Good luck. I'll catch y'all next time.